Hi everyone, I am Subramaniam Gantasala and I am currently working as a Senior Design Verification Engineer. So in this video, we are going to solve a SystemVerilog coding interview question. This question was asked to me in a very big company, and then this question is based on constraints and randomization. So it's a bit tricky, and during the interview they did not give me a full problem statement, but here for the sake of simplicity I'm just putting the full problem statement so that we can go through the statement and then start coding the actual SystemVerilog class for this. So the problem statement goes like this. So the example class defines and randomizes a parent array along with 3 child arrays. So we have a class called example and it has a parent array p underscore arr and then 3 child arrays with c underscore arr respectively. So these child arrays are subsets of parent arrays and they must satisfy the below constraints, right? So constraint 1, parent array. So parent array must have fixed size of 5 and all elements must be unique. So this is not a fixed constraint, but I have made it for simplicity. And then constraint 2 is on child arrays. First constraint says that the size of child arrays must be strictly smaller than p array. So each size of child arrays like C1, C2 and C3 must not be greater than p array. And each child array must contain at least one element. It means child array should not be an empty array. The sum of size of all 3 child arrays must be exactly match the size of p array. That means, so the sum of sizes of all child arrays should be equal to the size of p array. So it's like you are equally distributing the elements of p array into c arrays. Third one is element distribution and constraints. So each element of p array must be assigned to exactly one of child arrays. No element can be present in more than one child array simultaneously. Each child array must contain elements only from p underscore arr. So this means the child arrays should contain the elements of parent arrays and each element of parent array should be only in any one of the child arrays, not 2 or 3. So that means the child array element should not be overlapped. So C1 should not contain C2, C2 should not contain C3 and C3 should not contain C1, like that. And finally, so once you build a class which has all the constraints and randomness defined, so you have to create a test bench and then implement this class, randomize this class so that we can see the output. So now let's go to EDA playground and start coding this problem. So we are on EDA playground. So as we know, we can set some language and let's set a simulator. Let's set Synopsys VCS. Yeah, and then let's name this playground so that we can save and share later. So SV coding 1. Let's start with creating a class named example. So class example and class. So we need parent array and 3 child arrays. Let's create a 3-bit array so that it will be simple. So rand p underscore arr rand bit 2 down to 0. It's a dynamic array and let's create child arrays. 3 down to 0. So now let's start coding constraints. First, let's constrain P array. So first thing is we have P array size must be fixed to 5. So let's write that constraint. So the size of P array must be equal to 5. So next constraint is all elements in P array must be unique. So let's write that constraint. Constraint P underscore unique. So it's just unique. So we just use unique keyword. P underscore ARR. So now we have added the constraints for parent array. So let's write the constraints for child arrays now. So if you see the constraints for child arrays, the sizes of C1, C2 and C3 must be strictly smaller than P array, and each child array must contain at least one element, and the sum of sizes of all three child arrays must be equal to the size of P array. So let's code these three constraints for child arrays. So constraint is for better thing, let's call it C1. So as you see, C1 underscore ARR dot size plus C2 underscore ARR dot size plus C3 underscore dot size is equal to, so here we should put equal to. So this will make sure that the sum of sizes of child arrays will be equal to the size of parent array. And the next thing is each child array should contain at least one element. So it means the child array should not be an empty array. It's the same as constraint on the size of child arrays. So write constraint C2. So we can just copy this. So what do we need? We need size of C1 arrays should not be 0. Right? So let's write greater than 0. So C2 greater than 0 and C3 dot size greater than 0. Fine. Now the size of each child arrays should be less than that of parent array, right? So let's code that also. Constraint C3. So it's the same. We take C array dot size should be less than parent array, PRR dot size, right? So let's copy this for remaining two arrays. So here it's C3 and here it's C2. Done. What do we know? We know one more thing. In this third part, it says no element can present in more than one child array simultaneously. No overlaps between C1, C2 and C3. Also, one more thing we can write is all the C arrays can be unique. So we don't want any repetitive elements in the child array. So let's write constraint for that. C4, let's call it same what we did here. So we don't want any repetitive elements in the array. So let's write that. We need C1 underscore RR. So just copy this and paste for remaining. Okay, so now we have coded the size requirements for child arrays. Now the next thing is to code the constraints for child arrays where it gets the elements from parent arrays, right? So let's code that. Constraint C5. So let's call it C1 underscore elements, because now we are writing the constraint for C1 array. So how the C1 array elements can be taken from parent arrays. So how do you code constraint for arrays? Since you need to loop through each element, we use for each of C1 underscore ARR of I. So we are looping through each element of C1 array. So what do you need? You need the elements of C1 array should be that from parent array, right? So let's write C1 underscore ARR of I should be inside P underscore ARR. So this will make sure that whatever the elements it populates with C1 array, they should be inside parent array. Now one more thing is there to consider. So we need to make sure that the elements from parent array are not repetitive in different child arrays. So that means one child array element should not be present in another child array. So we can constrain that by saying the C1 array element should not be in any one of the C2 or C3 arrays. So it's a negative constraint. So we'll write not of C1 underscore ARR of I inside C2 underscore ARR, right? Similarly, and write the similar constraint where C1 is not present in C3. So C1 underscore ARR of I inside C3, and we are adding a not here, so it's negative. And then let's close the loop. So this bracket is for this loop, and then this bracket is for this constraints. Cool. So now similarly we can create the constraints for C2 and C3. So let's copy this and paste it for remaining child arrays. So now it is for C2 elements, and for each of C2 underscore array, what we can do, we can write C2 array of I should be inside P array, and then C2 underscore array of I inside C2 C3, right here, okay, C3, and then let's write C2 inside C1. So same thing you can write for C3 array, right? So constraint C3 underscore element for each of C3 underscore array. C3 array is inside P array, fine, and then C3 array is inside, let's write C1, and C3 array inside C2. So, and we have not, so that it will not happen. So now we have all the constraints we need. Let's go through them once again. So we have constraint to the size of P array as 5, just for the sake of simplicity, and then the elements of P array should be unique. So we have used a unique keyword for P underscore ARR, and then we wrote a bunch of constraints for child arrays which constrain their size and the element types. So the sum of sizes of child arrays should be equal to the parent array size, and then each child array size should not be 0, and it should not be an, that means it should not be an empty array, and then the size of each child array should be less than the parent array, and finally the child arrays should be unique. That means the elements inside each child array should not be repetitive. So after that, the main logic in this problem is we have to populate the child arrays with the elements of parent arrays, right? So how do you do that? So this is one of the way. I'm not saying this is the only way, but this is the way I have come up with for this constraint. So we can loop through each element of child array, and then we say that the element should be inside P array. So you take the element from parent array, and also you say that each element should not be present in any of other child arrays. So first constraint tells us that C1 array element, each element of C1 array will be inside P array. So we are taking elements from parent array. And the second and third constraint says that C1 array element inside C2 array, and there is a not. So it means the elements of C1 array should not be present in C2 array. Also the elements of C1 array should not be present in C3 array. And it is same for C2 and C3 also. So just change the names here, C2, and then it goes, for C2 it is C3 and C1, and for C3 it is C1 and C2. So now we are done with constraints. Let's create a test bench and run the simulation so that we can see the output. So let's write module TB, and then end module. So let's create the object and handle for this example class. So example ex1 underscore h, it's a handle. Let's create the object for that. Now initial begin. So what do we need in the test is we can create these arrays for some fixed number of times and then print those arrays so that we can see the output, whether it is following the constraints we have defined or not. So let's use a repeat loop. Set it for 5, begin, and let's randomize this ex1 underscore h dot randomize, right? And then let's print these values of parent and child arrays. So we have p array, and then we can use %p just to print the array directly. So p array and then c1 underscore array is equals to %0p, c2 underscore array is equals to %0p, and then c3 underscore array equals to %0p, right? So now let's give these actual variable names. So underscore h dot the first is our p parent array, and then ex1 underscore h dot our first child array, our second child array, and our third child array. C3 underscore array, and then begin end, and so it's done. So now we have the test bench, and let's run this and see. So I'll click save and then click run here. So as you can see, it prints parent array and 3 child arrays. So if you see, the elements of parent array are 2, 3, 4, 1 and 7, and C1 array has element 1, and then C2 array has 2 and 7, and C3 array has 3 and 4. So as you can see, all the child array elements are taken from the parent array, and there are no overlap or repetitive elements within the child arrays, and also the size of child array is less than parent array, and also the sum of size of child arrays is equal to the parent arrays. So this means whatever the code we wrote, it follows our defined constraints. That's all for this video. Thank you.